Good morning, everyone. Firstly, I present myself. I'm Dr. Zulika Sadek, Associate Professor Researcher as well at the University of Algeria. My pleasure today to present to you a part of my research work which about lanthanum promoted nickel-based catalyst for the dry reforming of methane at low temperature. So, for that, I will start with general introduction about natural gas and hydrotalcid as nanomaterial. After that, I will present their preparation and characterization with catalytic testing results, and I will finish with general conclusion and perspective. So, due or owing to economic crisis decreasing all in the hand, on the other hand, greenhouse effect and global warming, the global competition challenge to get and to find a new source of energy like hydrogen. So hydrogen is considered as energy vector of the future and can be produced by natural gas valorization. So we can say natural gas remains the safest and the cleanest source of fossil fuels. Different catalytic ways can be used to valorize or for valorization of natural gas. One of them, and we are interested for dry reforming of methane. So in this work, we will present dry reforming of methane study for 2 points. The first one, the decrease of two gases greenhouses like CH4 and CO2, and the second point is the production of thing as H2O. Different catalysts are used for methane dry reforming. The general, we use nickel-based catalysts because they are available and cheaper, but their major problem is their deactivation by active phase sintering or carbon deposits. For that, in the new and the great idea is to use material with well-defined structure like hydrotalcid. So by definition, they are hydrotalcid. They are laminar double hydroxide with divalent and trivalent metal. Their structure is based on stack of laminar of composition MOH2, similar to those of recent MgOH2. The hydrotalcid structure is obtained only by isomorphic substitution or topotactic reaction of magnesium with divalent and trivalent metals, with condition that the radius of divalent and trivalent metal should be around 0.65 angstrom, which is the value of radius of magnesium. This is the general composition formula of hydrotalcid, with M2 and M3 present divalent and trivalent, and In- is exchangeable ion located in interlaminar space, and X is the molar ratio. Hydrotalcids have different properties. One of them is the good dispersion of the metallic phase, which is property can be used in catalysis. Now, for the second part, it's about preparation of materials. So, different methods can be used, okay, to prepare hydrotalcid as material. In general, we use precipitation because it's easy to realize in the laboratory, and it's a cheaper and economic method. hydrosulfate before or after thermal decomposition, which means calcination step, are found in many applications. So, in medicine, for water treatment, in electrochemical industry by ion exchanger, and in catalysis as catalyst or supported catalyst. Second part is about characterization of material with different chemical physical technique. So, for elementary analysis, the analysis show that the molar ratio is close to 2, which reverse good operating conditions of the preparation of the catalyst. In addition, the value of molar ratio is include between 0.22 and 0.23, which means good crystallinity of hydrosulfide structure. And on the other hand, the specific surface area of the both catalysts is presented here. So we observe that nickel, magnesium, aluminium present high surface area compared to nickel lanthanum. So this is we can say that the introduction or the incorporation of magnesium in the same type of compound leads to increase in the specific surface area, which reveals that magnesium has this effect. For X-ray diffraction results, so before calcination, the structure is different to hydroelectric structure. So this is due that the large radius of lanthanum with its amount inserted into hydrostatic matrix. After calcination, the analysis presents only the presence of mixed oxide phase. For infrared technique, so before calcination, here we present all bonds presented, and after calcination, the analysis show only the diminution or the reduce of intensity of the bond due to the stress phenomena presented or occurred out under thermal decomposition, like dehydroxylation, and decarbonation. For RTP, in general, we can say that RTP analysis show that with the presence of displacement of the peak toward high temperature around 80 degrees Celsius in the case of nickel magnesium lanthanum compared to its homologue nickel lanthanum, and this result is due to the presence of magnesium. Now, for the last part, which about catalytic activity of gyroforming of methane. So here we present the general condition used for catalytic testing. So the results show that a great catalytic performance presented by the two catalysts, especially in the case of nickel magnesium lanthanum, so which present a great catalytic performance, catalytic activity, conversion of CH4, conversion of CO2, and also the selectivity. So this result is due to magnesium in the matrix of nickel lanthanum or hydrosulfide matrix. So we can say that magnesium develop and enhance the activity catalytic. On the other hand, we observe or we get that the conversion of CO2 is greater than the conversion of CH4. So this is we can explain by the presence of side reaction like reverse Watergate shift. So, and now as a general conclusion, we can say in this work lanthanum promoted nickel-based catalysts were prepared successfully by co-precipitation at basic pH which equal 11. So the structure was not obtained in the precursor state of the sample, so probably due or owing to the big or large ionic radius of lanthanum and or the large content of lanthanum in the synthesis gel. For gyroforming of methane, the two sample nickel lanthanum and nickel magnesium lanthanum catalyst did not show any reactivation during catalytic testing in DRM reaction that we attribute to a favorable promoting effect of lanthanum. And nickel magnesium lanthanum present a great and a much higher conversion and selectivity than nickel lanthanum sample. So this is also pointing the beneficial effect of magnesium in combination with lanthanum. And thank you so much for your attention.